Hey kids, welcome to 2021. You probably have forgotten a lot of what we did before Christmas, and I totally understand that. Um, but we're continuing on with energy. Remember kinetic and potential. If you don't, maybe you should go back and look, but I think we'll catch back up. Um, our PowerPoint today, there are questions that go with it, and you'll have Monday or Tuesday to both finish these questions. Okay. And then I'll talk to you in the daily announcements as well, but there'll also be some IXL coming up. All right. So we're going to look at different types of energy today. Okay. So there are many different kinds or many different forms of energy. And we're going to look at all of these today. The titles are, or the names are mechanical, sound, electromagnetic, which we talked about way back in the fall when we did light, electrical energy, better known as electricity, chemical, which comes about because of chemical changes, thermal, which is heat, and nuclear, which is a type of power that we'll get into a lot more in the spring. All right. Energy is typically expressed, or the label is joules. We won't do a lot of that, so you don't need to worry about that. All right. First of all, mechanical energy. And mechanical energy is the sum or the total, make Pratt mad, make Pratt happy, if you know what sum means, of the kinetic and potential energy combined. So it is the motion and the position combined. Okay. So it can be all kinetic, or it could be all potential, or a little bit of both. And we're going to look at a couple examples here. Okay. So for instance, if you're hammering in a nail into a board, you have potential energy to begin with. As it moves, you have kinetic. And then at the end, those totals are mechanical. Same thing with a bow and arrow. So just know that mechanical is the combination of both. Next, and again, we did this fall, sound energy. Sound is kinetic energy, so the particles are moving, and it's vibration. Remember? The vibration of the particles. And so the sound, remember we had sound waves as the sound moved through the whatever it was moving through. Remember that it has to have a medium, or it has something to vibrate through. Okay, so it cannot happen in space. So that is sound energy. Next, something else we did this fall, electromagnetic. Okay, that's basically light. Well, it's the whole electromagnetic spectrum, but light is included in that. So electromagnetic energy is transmitted, big word, nice science word, flows through space in the form of electromagnetic waves, which are caused by the vibration of electrically charged particles. Okay. So again, as we talked about this fall, there's radio waves, microwaves, infrared, visible light, which is kind of what we care about, ultraviolet, X-ray, all of those things. And here is an example. Again, I think we talked about this some this fall, about the different wavelengths and what they are, and visible light on the electromagnetic spectrum. Okay. This next one we kind of care about because it's real important in our lives, electrical energy. Okay, and that's the energy that results from the position or motion of charged particles. Okay, it is generated or made by the movement of negatively charged particles. Now, do remember back when we did the atom, okay, that's the electrons, okay, and that's how it is mentioned. Remember, we have protons, neutrons, and the electrons are flying out around the electron cloud. Okay, so the electrons travel from atom to atom in a wire to create a current. Okay, so now with just those ones we've talked about, let's look. You guys probably video, or not video games, but these type of games you probably aren't even familiar with. Pinball machines, because they're kind of older school, but maybe you've seen them. All right. But let's look at this question. What would be 3 forms of energy in this image? Okay. Now, this is a big pinball machine, so think about that. Well, can anybody think of one in your head? What would these be? Those are lights So that would be, well, we go down here, mechanical. That would be a little bit of both. Up here would be the lights, so we would have electromagnetic. And here, when the pinball is hitting these sound things, it makes loud ding, 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 ding. Okay, so that would be sound. Good. All right, so let's look at the next question. How does electrical energy differ? So electric energy differ from electromagnetic. That's a really hard question, and I don't expect you to know it. But let's look at the answer, please. Electromagnetic energy is caused by the vibration of the charged particles, but electrical energy is caused by the position or the motion. Okay, so that's really hard, and I'm not going to spend a ton of time in worrying about you like knowing that super well, but know that the electromagnetic is the vibration and the electricity is the movement. All right, let's look at number 10 here. Would you expect to detect electrical energy if you played the pinball game shown in the picture? So if you were playing this pinball game, do you think there is electrical energy? Well, absolutely, as it says. Electrical energy can be detected by the lights, by the sounds, by the motion. All of that's powered by electrical energy. Okay, now this next one's important. Well, they're all important, but chemical energy. Okay, so that is potential energy based on the arrangement of molecule bonds between the atoms. Now, we've done a lot before Christmas about chemical changes. Well, that's where this comes in. Okay, during a chemical change, the bonds between the atoms break and then new bonds form, releasing chemical potential energy. You know, we get a new substance. Think back to all of those notes. All right. So, chemical change examples: burning gasoline as fuel, digesting food, that's a biggie, using batteries. Those are all chemical changes, which are chemical potential energy. All right. So, when you're with your parents or brother or sister, grandma, grandpa, whoever, you have to put gas in the car. Okay. When the gas is burned, that releases chemical potential energy, which then your engine can use to make your car go. Same thing with food, okay? When you eat your food, we've talked about it and kind of laughed about it, okay? But your hamburger is no longer your hamburger once it gets digested, okay? So that turns into chemical potential energy. And lastly, same thing with batteries, okay? You put them in a flashlight or something that requires batteries, that releases chemical energy. All right, next on our list is what's called thermal energy. You might know this from 4th or 5th grade as heat, okay? We've talked about this a little bit. In fact, there was IXL about this, okay? The faster the particles are moving, the higher the temperature, okay? And also, and again, I know there was IXL on this. In fact, I made help videos about it. The more particles, the more thermal energy there is. So let's look at this cute picture of the mama elephant and her calf. Which one would have more thermal energy, the mom or the calf? Well, it would be the mother because she has so much more matter. All right, and this is important to know, and we'll talk about this more in the next couple, 3 weeks. Heat is always transferred from an object at a higher to an object at a lower. It's going to go warm to cold. So if you have an ice cube and you put it in warm water, does the ice cube make the water cooler or does the water melt the ice? Well, the water melts the ice because it's going from warmer to cooler. All right, and our last type of energy is called nuclear energy. And it is harnessed or collected when an atom's nucleus, remember back to the atom, you've got the nucleus, okay, neutron and proton, okay. There is a way that is broken apart using what's called uranium, and we'll get into that later in the school year. That's called nuclear fission, okay. It's broken apart. Or when they have nuclei, which is the plural, come together, and that's called nuclear fusion. Anyhow, either one of those processes releases a tremendous amount of energy, and that is called nuclear energy. Any of you are into history, that is how the United States ended World War II, by a bomb made from this type of energy. Okay. So let's look at this question. Why is the chemical energy of a battery potential energy and not kinetic? Really good question. And you might have this as an actual question later on. Okay. But the energy in the battery is stored up. Okay. It has to be placed in a circuit, like in a light, flashlight. Okay. The battery would be attached and then the wires would connect the circuit. Okay. Well, it has to be a circuit in order for it to release the energy. So prior to that, it is stored, which means potential. All right. That is it for today. There are questions for you to finish. I'm fading away. For you to finish on Canvas. If you need me, please message me and I'll get back with you. All right. Take care. Miss you guys a lot. Bye.